Now let's talk about pivoting with proxy chains. Proxy chains is an application that allows you to force a non-proxyware application to use a proxy. The way it works is you have to edit a global configuration file, and that is etcproxychains.conf, and make it point to your SOX proxy server that you want to use. And then you can do proxy chains, any command you want, to run that command and make it tunnel traffic through the specified proxy server in proxychains.conf. For example, here's what that looks like. If I do proxy chains SSH user at target, proxy chains will create SOX traffic to the team server and make the SSH program become proxy aware. The SSH program is our application traffic, and that application traffic will go through our beacon traffic, and it will come out through the pivot host, and the pivot host will interact with the target system on our behalf. So that's what pivoting with proxy chains looks like. Okay, let's demonstrate proxy chains. Here's the scenario. We're on a developer system, and we had to chain a few levels to get to this particular developer system. Okay? Now we started logging keystrokes, and we started capturing screenshots of user activity. And it looks like the user is editing some kind of source code, and we want to get that source code. Okay? Fortunately, from our keystroke logging, we have a username and password. So what we need to do is jump onto the system, figure out where the target's connected to, and we can do that with a netstat. Okay? And we can see that they're connected to this system on port 22. So that's our candidate to connect to. So we're going to use proxy chains to get to that particular server. So let's go ahead and do it. First, let's make this beacon interactive. Now, when you change the sleep time in a SMB beacon, what you end up doing is bubbling a task up to the parentmost beacon to change its sleep time. Okay? So now that the parent is interactive, we should be able to create a SOX proxy on this particular system over here. So let's do port 3333, hit launch. And let's head over to a terminal. And let's get the IP address of my team server, because I'm not going to remember it. There we go. And let's edit etcproxychains.conf. And we're going to make proxy chains go through the proxy server on our team server, port 3333. Cool. Now, let's get our target information. 192.168.57.18. User is Jay Sokol. Password is Josh Rocks. So let's do proxy chains, SSH, Jay Sokol, at, paste, and there we go. This SSH connection is riding down that pivot chain and through that final Linux system. And here we are. We're able to navigate around the system, find stuff. Oops. Probably didn't want to do a find slash. But we're able to navigate around the system and go looking for things. So that's an example of using proxy chains with Cobalt Strike's beacon. Let's talk about reverse pivoting, turning a compromised system in blue space into a redirector for some sort of service in red space. You can do this with the rport forward command. This command sets up a reverse port forward. The first option is the listen port, the port that the compromised system will receive connections on, and the second parameters are the forward host and forward port. These parameters specify where Cobalt Strike should forward any connections that come to this listen port on the compromised system. You can stop a reverse port forward with the rport forward stop command as well. One thing to note is that you have to take into account whether or not there's a host-based firewall on the target and create an exception or disable the firewall for this mechanism to work. Okay, a Cobalt Strike feature that builds on top of reverse port forwards are pivot listeners. A pivot listener is a Cobalt Strike listener that calls home through a beacon session, in effect making the compromised system a redirector for that payload handler. To stand this up, just go right-click on a beacon, go to Pivoting, Listener. Okay? And here, you can give the listener a name. You're going to specify the payload as a foreign listener because this is basically an alias for a payload handler elsewhere, maybe in another Cobalt Strike instance, maybe in Metasploit, that we're going to create a reverse port forward for. You're going to specify the listen host and listen port, which is your compromised system that is acting as a redirector. And you're going to specify the remote host and remote port, which is a system in red space that is ready to receive a payload, the payload that we specify. Okay? And here's what this looks like graphically. We have the remote host in red space that is listening on the remote host and remote port that we set. Okay? We have a compromised system in blue space. That is our listen host. We can attack a target in blue space and reference the pivot listener. And when we do, the target will connect to the listen host that is our redirector. The listen host will tunnel that connection back to the team server, and the team server will in turn route that traffic on to whatever forward host and forward port we specify. Okay? So that is the concept of a pivot listener. Okay, let's take a look at using Beacon's reverse port forwarding capability to turn a compromised system into a redirector. Here we are with our foothold in the Acme network. We have the file server chained through the What-A-Hog system. Okay? So what we're going to do is we're going to create a redirector out of this system, the file server, that points to port 80 over here in Cobalt Strike. So let's go Pivoting, Listener, and this will create a reverse port forward and a foreign listener in one step. So let's go ahead and call this redirector. File server HTTP beacon. Make it a little bit more short. We'll just do an R like that. Listen host 10.10.10.4. We'll listen on port 80. And we're going to forward all traffic over to ads.losenolove.com, port 80. Okay. Hit save. And there we go. Now, very important. Don't make the mistakes I've made. Do a sleep 0. The sleep 0 will make this beacon interactive, or at least its parent, so that things are pretty responsive. Cool. Now that we've got a port forward pointing over here, let's go ahead and create a listener and tell it that it's 10.10.10.4, port 80 is where it stages. And we'll call this redirector HP beacon actual. Doesn't matter. Configuration's same anyways. 10.10.10.4. Looks good. Okay. Now, let's go ahead and make an attack. We'll do the HTML application, and we'll tie it to our listener configuration. It goes through the redirector. Hit generate. Call it evil.hta. And let's go ahead and host this on our web server. Okay? As evil.hta. And let's point this towards our redirector, 10.10.10.4. And there we go. Now, let's go fishing. Let's go to attacks spearfish. And what we're going to do is use the same template from earlier in this course. And we're going to embed the URL of the file that goes through our redirector. I guess we could just as well attach it. And let's go ahead and hit send and kick off our phishing attack. The main point is we've just kicked off a phishing attack where the malicious content is hosted inside the target's network, and our initial callback comes to a system inside the target's network. Okay? So let's come over here to ads.losenolove.com, go to weblog, and let's watch what happens when target decides to check their email. Okay? So I'm target. I'm going to open up my email, and you can see a hit on the HTML application. I'm going to allow it to run. And there's our stager, and here we go. We now have a foothold in the Acme network going through the file server. So the file server is our redirector. Okay, let's talk about tunneling beacon over SSH. Here's the scenario. I have a system in red space that can talk to a Linux system in blue space, okay? That Linux system can reach a target I want access to. Now, presumably, I have the information I need to attack that target. Either the information to establish a trust relationship or maybe an exploit if I want to tunnel that through. But for this, we're going to assume we have trust material. Okay? So the main idea is I want to be able to attack that target in blue space through this SSH tunnel I create from red space.